Hello, this is the final video, or the final class. It's actually kind of an extension class, just a review of some really important stuff in Unit 6 and 7. In fact, key information in Unit 6 and 7 that if you know how to do this, you should get really good marks on the final for those two questions. And then I'm going to do just a selection of problems from Units 1 to 5. What I'm going to do essentially is I'm going to have this extension sheet done. I'm going to have a small break, and by break I mean I'm going to ask you if you have questions, and then I'll go into the review sheet. And by questions I mean, okay, maybe you misunderstood something in Unit 5, maybe you want to remember something about Unit 2 or 3, things like that. But before I start into the worksheet content, I just want to be crystal clear here. On Saturday, for your final, the final itself, the D2L quiz, opens at 8 o'clock. Okay, that's the first point. But you need to start joining the group. You need to join the Zoom meeting on that day at 7:30. Okay, because you need to make sure that the Zoom is all set up, because the way it's been structured, you need to have your video on. Okay, you need to show your face, you need to show your work desk. It would be the same thing as, you know, if I pointed to this camera down, showed my work, showed me working, showed that I wasn't texting someone, showed that there wasn't any tutors or anyone else around, that kind of thing. I know that's not ideal for a lot of you, depending on your situation. And for sure, for me, like I have my kid running in sometimes, but anyway, that's the way it is. You need to find a way to make it work. So on Saturday, 7:30, you need to come into the Zoom room. That gives you a full half hour to make sure that the camera is working properly, okay? It's not going to be shared. I'm not putting this stuff on YouTube. This is just for me, okay? I'm going to be in the rooms making sure that everyone is there and everyone's doing the work. And if you're concerned about not wanting to show your face, well, first of all, if you're coming to campus, you're showing your face anyway. So I know you're not comfortable sometimes, but like it's just, you've also come to a co-ed college. But the more important point, I'm gonna make breakout rooms. So any females that want to be only with female, I'll make a female breakout room and I'll make a male breakout room. And I'll just have two separate rooms and I'll just join both so I can watch both of them, okay? So if you're not comfortable with you being on camera for any reason, you know, if it's a male-female thing, just let me know. You can send me a personal message. It's not a problem. I'll get it all sorted, okay? But you will need to have your camera on, just so I'm clear. So long story short, today's review on Saturday, join the room at 7:30. The exam starts at 8. The reason you need to come in at 7:30 is because you need to get your camera working properly. All right. Any questions at all before I move on to the very beginning of this worksheet? This worksheet is on D2L right now. I also sent it in the WhatsApp group. All right, I'll just assume, I'll take that as a no. And hi, Ibrahim, I just saw you there. All right, let's do a quick review of curve sketching and we'll move on to the overall review. The reason I put this kind of cheat sheet here is to remind you what the parts of a curve look like, because we're going to be getting questions like this. You might get one like this on your final or something similar, and just ask you to figure out what the slope is doing and what the concavity is at a given point or on an interval. So if the curve has any shape, any part of the shape looks like this, any part of that curve is called concave up. So you'll notice that this curve has part of that curved up shape. This is curving up, which is why it's concave up. All right. Same thing with, so the second derivative is positive. That's what that means. If second derivative is positive, it's concave up. So of course, how tables work, this is all concave up. If you look at this, this is slope. Let me make a better color. This would be positive slope, positive slope, positive slope, which means F prime is greater than 0. So the slope is positive. That's what f prime greater than 0 means. The function would be increasing, getting bigger at that point, which of course you should be able to see. From left to right for this one, the slope is actually negative, which means the f prime is less than 0, also negative, and it's decreasing. And we can see that. If you had a ball, you know, you put it at the top of that hill, it would roll down. The slope is negative. You'll also notice if you compare, if you look at this part of the curve, that's concave down. This is also concave down. So all of this is concave down, also known as f double prime is less than 0. Okay? And finally, with your slopes, it says it's positive and negative. Well, that should make sense. This is a positive slope section. This is a negative slope section, which is why we get the results that we do. So long story short, let me give you a shorter way or a little tiny extra cheat sheet here. This means f prime greater than 0. This is f double prime greater than 0. If you have both of those things happening, both greater than 0, this is what the curve looks like. It looks like this. All right? If you have f prime less than 0, but f double prime greater than 0, it looks like this. If you have f prime greater than 0 and f double prime less than 0, it looks like this. And if you have f prime less than 0, f double prime less than 0, it looks like that. Okay? So I'm going to just move ahead and we'll figure out the answer to these questions based on this cheat sheet. Okay? Let's look at this. Check your understanding. Describe the graphs below using f prime and f double prime using the following terms. So it says f prime greater than 0 or f prime less than 0, positive or negative. And then f prime greater than 0, f double prime greater than 0 or f double prime less than 0. Let's take it piece by piece. Let's look at A. You can see the function here to the left. That's the one we're going to be looking at. In A, it says f prime on the interval negative infinity to 0. So from negative infinity to 0, just look at this graph. That's everything to the left of 0. So the function here. So that function in that section looks a whole lot like this, doesn't it? Which we can say, what's the slope? Is the slope positive or negative in that point? In that section here. Is the slope going to be greater than 0 or less than 0 from negative infinity to 0? Hello. Well, it would be, the slope would be positive because it's going uphill. So Abdullah, you said less than 0. It's not less than 0 because we're going uphill. If from left to right, we have to go up. Okay, the function's actually increasing even though it's curving downward. That's not related to the slope. So look at this. We have positive slope, positive slope, positive slope, positive slope, positive slope. Okay? So we have f prime is actually greater than 0 on that interval. Just draw any given number of tangent lines. It'll show you that it's going uphill. Let's look at the concavity. Remember, the slope is related to if it's going uphill or not. The concavity is related to if it looks like this or if it looks like this. So does it look like downward or does it look upward in that region before 0? Well, it looks, to me, for sure, it looks downward. So we have downward, which means that our answer, it's less than 0 on that interval. Okay, so you'll start to make sense of this as we go. In this interval, it definitely looks downward, and the slope is greater than 0. So what we'll see here is that f double prime is actually negative, f prime is positive. If you look back at your cheat sheet, we have slope positive, concavity negative. It should look like this. And do you see what I'm talking about? This slope greater than 0, concavity less than 0. It looks like this. That's exactly the type of shape that I just looked at. All right? So I'm just trying to get you to understand how curves are sketched and their main properties, first and second derivative. The more of these we do, the easier it's going to get. So let's look at the interval from 0 to 3. I don't need to make that colored. So from 0 to 3, it's this interval inside here. Okay, from 0 to 3, we're looking at this interval here. So if we just look at this part of the curve for now, is the slope positive or negative? The slope. Does it look flat? Does it look like it's going uphill, or does it look like it's going downhill? Well, definitely in this case, yeah, Aisha, you got it. The slope is negative because if you were to draw a tangent line at any point, you would have, it would look down. It would look like it's going downhill. So in this case, the slope is actually less than 0 on that interval. For concavity, similar idea. What's the second derivative? Is it curving downward or is it curving upward? That one's a really easy one to see. It clearly looks like this. I mean, it's part of a downward curve, which means concavity is downward. So negative and negative, that's all I'm looking for on that interval. Okay? I hope it starts to become more clear. Once again, I'll compare it. Negative and negative looks like this. Okay, let's look back at our cheat sheet. Slope negative, concavity negative, it matches. So I'm going to start speeding up because this will get easier as we go. From 3 to 4, which is this little section of the curve right here. That one's a tricky one. You know, don't jump to conclusions here. I want you to tell me what the answer is. Is the slope in that negative or positive? From left to right, is it going down or up? Well, from left to right, going down, it's decreasing. So the slope is negative. So the slope is less than 0. And then the concavity, does it look like part of a happy face curve, an upward curve, or a downward curve in that section? If I look really carefully, it looks like it's still part of an upward curve. So the concavity is positive, the second derivative is positive. All right, so we have many different cases. And once again, if I look up, slope positive, concavity positive, sorry, slope negative, concavity positive, looks like this, which is exactly what we just talked about. Okay, and the last one, I can see that the last one, the slope is positive. It's going up, it's increasing. And the concavity here is again positive. So we can fill in our answers. That's from 4 to infinity, so forever. So I hope this is making some sort of sense. If you understand this, you have a really good chance that you're going to get that mark on the final. Okay? I know it's only 1 mark, but every question, you know, there's only 10 questions, and they're all worth 2. So it's worth 2%. It should be a freebie, really. It should be an easy mark if you understand this. By the way, I'm so proud of this mug. You see this mug that I use? You see this Mario mug? And it's dark on top. When there's hot coffee in it, it shows the Mario scene. When there's no hot coffee, or when the coffee is no longer hot, it goes all black. It's like my favorite thing ever. It's the little things in life that you gotta hold on to, right? To make you happy. So you can follow my coffee progress as we go through the class. I think I found it on ThinkGeek, but I don't think it's still on ThinkGeek. There's similar ones, but this one I think is special. Okay, let's do one more. This one, I'm going to go through this one quickly because you can always rewatch this video. I've already set up the basics. Let's see what we have here. Our intervals are from negative infinity to a, so everything before a. I'm just going to make a line here. This is our interval. Our curve here, that's definitely concave down and slope negative. Slope is negative, and it's concave down. For the next interval, from a to 0, that's a little small interval between a. We don't know what that number a is, and it doesn't matter. We just need to look at this interval here. You should be able to tell that that's increasing, getting bigger, and it's concave up. It's that upward curve. And so we have a positive slope and a positive concavity, or a positive second derivative. Between 0 and b is my next interval. You'll see I'm just looking at these intervals here. Between 0 and b, what's this? This is increasing. For sure, the function is getting bigger. The slope is positive, but the curve itself, if you look at it carefully, it looks like this, which is kind of like part of that curve, a downward curve, a concave down curve. So let's see, we have slope positive and concavity negative. Let's finish this. From B and everything bigger than B, this is that section. The slope, it's down. Of course, it's down. You should be able to see that. And concavity, positive, upward curve. All right. So every single one of these groups, you can take this, you can compare it to the cheat sheet that I wrote at the top of the page, and you should be able to see why I'm making the connections that I am. Okay. So that is the review for Unit 6. Believe it or not, that summarizes, those concepts summarize the concepts that we did in Unit 6. Not the calculations, but the real big ideas, the takeaways here. Because you can see the maximums, you can see the minimums, you can see the intervals, things like that. One last thing I'll write is that we were writing, you know, between the maximums, we were writing these number lines. So when we did this, we were saying, hey, a to b, and then we had a first derivative, and we were checking our derivatives. We were saying, hey, negative is a positive region, this is a negative region. So we knew we had minimums, and we knew we had maximums. These concepts are all what we did in Unit 6. We just aren't showing all the calculations this time around. And if we had gone a little bit further and done the concavity, which we only touched on, we would see that it would be negative, positive. We would have had an extra little 0 in here to say negative, and then positive again. But we won't get into that. That's for another course. You'll cover that again in Math 3, which I'd love to teach you. But who knows, maybe by the time you do Math 3, Math 2100, I'll be your instructor then. And maybe you'll be in person. Who knows? Shall we move on? You're probably ready to move on, and you're probably chomping at the bit, as they say. So this, once again, I put this in the WhatsApp group. It's also on D2L. It's on the front page, which this is probably the last time I'll be able to show you anything on D2L because we don't have any more classes. So I'll just show you exactly where to find the things that I'm posting. By the way, I've been having trouble with Zoom, and I've been having trouble with, I see your question, Aisha. I've been having trouble with Zoom, and I've been having trouble with D2L itself. Some of the final answers are not posting. So for in the content section, some of the things I'm posting are not showing up no matter what I do. I haven't quite figured out why yet. And I'm pretty good with this, so I think it's a D2L problem. But anyway, I'll put everything you need in the news section. So I'm saying I'll practice these key concepts. This, if you just tap on it, of course, will bring up the worksheet that I just did if you need quick access to it. And also I've put, if you look downward, some students couldn't access the notes. Let's see. Yeah, no, it was actually the answers I couldn't find. Anyway, my point was the stuff we're doing today, it's all in the news items. And if you can't get to the Zoom recordings, just check the YouTube. Check it on YouTube because D2L is having problems. For example, let me check content here. Normally I put everything in content in course notes, if you go to the bottom here, it stops at 5, even though I, for a fact, have put all the content in from unit 6 and 7. So you'll have to get that from the WhatsApp group for now until I find some way to give you full access to it. I don't know why that's happening. I wish I could fix it, but somehow, even though it's not posted there, you can still go to the notes in the news feed. So it is in the background, it's just not there. I don't know, I can't figure it out right now. Anyway, that's that. So Ayesha, your question was B to infinite, up or down curve. So in this point here, you're talking about from B onward. So everything from B and greater, is this an up or down curve? Well, you tell me. That curve here, if we finish the story, it's part of kind of a bowl shape, right? Like you can put some cereal in that. That's a upward curve. So it's part of this curve, which is concave up, or second derivative positive, also known as greater than 0. Is that okay? So you can always sketch less than 0 looks like this, greater than 0 looks like this, less than 0 looks like this, greater than 0 looks like this, for the second derivative, and so on. For the slopes, less than 0 looks like this, greater than 0, less than 0. Maybe that'll help when you look back on it. Okay, let's see, make sure I've done all the matrix stuff. I'm pretty sure I did last class. And yes, I did. This solution, this is just an extension. Because it's multiple choice, I won't be asking so much about that, but you would use your calculator to solve this. And I'll just give you the basic setup so that you have it. You would have x equals to A inverse of C, which is the last thing we did yesterday. Or in other words, to find x, y, and z, you would take your coefficient matrix, so take all your numbers in front of your coefficients here, sorry, all the coefficients in front of the variables, get the inverse of that using your calculator, and then in this column matrix, you would put in your third values. So this is x, A inverse, and C. You would do this multiplication on your calculator. It would give you your numbers here, and it would give -2, 1, and 3. So this is, again, calculator. And so we can see x must be -2, y must be 1, and z must be 3, which is why our answer is the way that it is. Okay? So I know I didn't show that on the calculator just then, but this is how you would do it. I'm just not focusing on it so much because I know what I'm giving you on the problem. Okay, let's move on. Before I do this extension, other final review sheet, do you have any specific questions for me from any of the units that you'd like me to cover now? Because I want to focus on your questions before I do this review sheet. Are there any questions for me? Abdullah says no. Anyone else, yes or no? You can just point me to the unit, you can point me to the page, any of that. Okay, looks like no. By the way, let me show you now, just my last chance. This is what it looks like when my coffee is now cold. You can see it's the second level of the Mario. Why am I putting the in front of everything? Second level of Super Mario Bros. On the ground. Okay, anyway, let's begin. You might remember complex numbers. It was unit 1. And one of the key questions, which used what was called de Moivre's theorem or de Moivre's theorem, or there's many ways to say it depending on where you're from. This is how we got complex cube roots or complex square roots, anything like that. Let me give you the quickest way to do it. Let me give you like the shorthand way. So we need cube roots, right? So what we do, we take our number, -27j, and in order to get the cube root, Well, you want to get the cube root, which for de Moivre's theorem or de Moivre's theorem, you need to put it in power form. And if you put it in power form, we can then use it. But the problem is we also need to get it into polar form. So this right now, let me make a little chart here. What we currently have is rectangular form, negative 27j. And what we want is polar form. You might be able to remember this from way back when. Negative 27j, if we were to graph that, well, what is it? It's actually straight down. Remember the real, let me write this down. The real axis is your left and right. The imaginary axis is your up and down. So it's negative 27j. That means it's 27 down because it's negative j. This is the negative j direction, and the r is 27. The important piece here, we actually need to know what the angle is. So in order to get from 0 all the way down to the negative 27, that's a 270-degree angle. So my whole point is we know r and we know theta. This is 27 angle 270. All right? That's a very quick review of what we covered before. Let me give you a couple other cases that might happen. So for example, these are just examples. Other cases, you might have rectangular form of, let's just say it was 27. What would that be? Well, that would be 27 in the real direction. It would just be 27, the regular number 27. So polar form for that would just be that. It would be 27 angle 0. That would be how that would work. If we had another example, what if what's another case? We could have negative 27, or let's just give a different number, negative 5. The polar form would be 5. What would the angle be? Well, negative 5 is left on the real axis. So it would be 180. And if I was to draw that, it would look like this. 5, and then our angle would be 180. Okay. There's only one other case that I haven't covered, and that would be if you had a positive imaginary. So let's just say the rectangular form given was 3j. If you had 3j, the polar form in this case would be 3 angle 90 degrees. And the reason is we have our real and imaginary axis. 3j is straight up 3, and the angle between those axes is 90 degrees. So those are the only 4 possible cases I would have you do. We've done more complicated cases where you use tan, but for the final, and because it's just multiple choice, I'm trying to keep it straightforward. So these are 4 possible cases you might have. So let's go back and try to remember why we did that polar form. So we have our polar form now. Why do we do that? It's because we want the cube roots. So we want the cube root of negative 27j. So we'll just, actually I'll write it over here. Sorry, I'm just trying to figure out the best way to write this on the page. We want the cube root of that, which is also this. Okay, because this is this. If they're the same, then we're allowed to put it in this form. And the reason we put it in this form is we need to use de Moivre's theorem, which only works with polar form. So if you remember what you do, you take the power and you distribute it onto these. The trick is the first part, it becomes a power. For the second part, you might remember, it becomes a multiply. So it comes down as a 1/3 and you multiply it. And then we just solve those. If you solve those, the cube root of 27 is 3, and 270 divided by 3 is 90. So that would be your first cube root of 3. We have 3 cube roots. Should make sense because there's a 3 here. what do we do next? Does anyone remember what the next step is? There's one little step. Everything else almost is exactly the same. There's one tiny step I need to do, which is affecting the degrees. Add 360, good. So you remember this. So you have to add 360 to the angle here. If you add 360, in this case, I think we get 630. And the rest of the story is the same. It's still 27 root 1 over 3, 360, sorry, 630 divided by 3. You can actually skip this middle step, go straight to the last step. I'm just showing you every step. You actually would get 210 degrees. We've continued the story. We finish once we have 3 roots because it's cube roots. If you add another 360 to 630, you get 990. And again, you can skip steps. You just do as many steps as you need to make sure that you know what you're doing, because of course it's multiple choice now. I can't see your work. Well, I can sort of because you're going to be on Zoom, but the quality of your work is up to you. Make the best notes that you can to make sure that you know what you're doing. And if you make a mistake, you can always go back to your workings. That's the reason for making them. So divide 990 by 3, it's 330. And these would be our answers. Okay, so that probably broke your brain a little bit if you haven't reviewed this stuff yet. You're like, oh yeah, I guess we did do cube roots. Believe it or not, it was only a couple months ago. I don't even think it was, when was it? I don't even know if it was 2 months ago when we started classes. Let's see if our answers are correct. 3 and 90, 2 and 2, 3 and 270, 3 and 330. Yes, they are. Okay. Any questions on that before we move on to the next unit? All right. As usual, if you need me to go back over anything, you just say, sir, and tell me. But if you don't know my techniques now, at the end of the term, you probably never will. By that, I mean the way to get me to stop. I just hope that I'm clear. All right, so that's just one of many questions in the complex numbers. It's just one that students tend to mess up. And I think it's important to know for the final. Unit 2, functions. For the function function y equals 7x minus 12, what will be the equation of the new function after a vertical translation of 4 units up, horizontal translation of 1 unit left, and a reflection through the x-axis? So you might be thinking, oh man, I don't remember this at all. So this is why I'm here to help you. Let me break this down. A vertical translation, 4 up means that we need to subtract 4 from the left. If we have 1 left, we need to add to the x. So I'm just going to show you that. If we're reflecting in the x-axis, we have to make negative y. So I'll do that third. So here we have y. If it's going 4 up, we need to subtract 4 from this side. Remember, it's all opposites. So if it says 4 up, you need to subtract, and so on. 7, well, the x, it said it's going 1 left, which means we take our x and we actually add 1, and then subtract 12. So what I did, if it's 4 up, you subtract. Up means minus. If it's left, you actually go plus. So take the opposites. Hopefully you can see that. So let's solve that for y. So you would have y equals, let me just open the brackets here. We would have 7x plus 7 minus 12 plus 4. Again, I'm bringing the 4 over to the other side, and we have y equals 7x. And what's that? Is that a minus 1? Minus 1. So what I've done at this point, I solved it as if there was a translation of 4 up and a translation of 1 left. I did them both at the same time. That's kind of my first step. So I'll just say this is the first step. The second step, which I'll put over here, is my reflection through the x-axis. And all you need to do, you need to put a negative in front of the y. Or in other words, you change all the signs on the right side. So doing this is the exact same thing as multiplying the whole right side by the minus. And this will give us our final answer, negative 7x plus 1. So I'll move this around the page a little bit just to make it more clear. But let me know if you have any questions on that, because if you don't, I'm going to be moving on. Okay. Anything I need to go back over? Going once, going twice. I'll call it no. Next question, also in functions. This one messes students up sometimes. I'm only going to show you one. Of course, there are many word problems in the functions unit. I'm just trying to give you some basics, some things to think about. How to take your numbers from the question. How to figure out which formulas to use, and how to rearrange some stuff and why. So let's look at this question. It says a right cylinder has a volume of 1,000. So the diagram I've already put there. You may or may not have a diagram. So it says cylinder. So just be careful if you don't have it, maybe draw a little sketch. It has a volume of 1,000. So right away, I'm going to say my volume is 1,000. So my volume is 1,000. Okay. And it says determine the surface area. So if it's talking about surface area, if that's the one that I need, well, I should probably write that down, the area. And it says it needs the surface area as a function of the radius of its base. Okay, so I need A in terms of R. So you might remember when we did this in functions, the first thing that I always do, I'll write the things that I need, but you should also write out the formulas. So I'll move this over here. I'll keep it there just in case you wrote that. And it's talking about volume and surface area, right? The questions themselves talk about volume and surface area. So we're talking about cylinders. So write out the formulas for these. What's the volume of a cylinder? You might not know it already. I'm going to be sending forward a formula sheet just so you have a reference. But the volume of a cylinder is pi r squared h. All right, that's your first thing that you should know. If you need it, you'll have a formula sheet that I'm going to send to you. The other thing is we're going to need surface area, so we need to at least write down the equation for area, or surface area of a cylinder, which is 2 pi r squared, which is the top and the bottom, if you have the bottom circle. So the area of the top, area of the bottom, those are two circles, 2 pi r squared, and then the side is 2 pi r h. I'm not going to go into why. If you understand it, it's fine. If you don't, you can just use the formula. And what are we trying to do? Well, we're trying to solve for area in terms of radius. But you might remember we have this annoying h that we need to remove. We need this in terms of r. So what do? We use our other equation, solve it for h, and then put it back into the area. So what I'll do here is I'll start over here, number 1. What do we know? We know that volume is 1,000. It was given earlier up top. So I just took this and put it down in here. This gives us that volume is pi r squared h. I need to rearrange that for h, and I can put it into my area. So h in this case We'll divide both sides by pi r squared h. So pi r squared. H must be 1,000 divided by pi r squared. This is my h. If this is my h, I can go over here and substitute everything in. So A is 2 pi r squared plus 2 pi r. Now I put in my h. Simplify and you'll be finished. You have area in terms of r now. So this is all in terms of r. Okay, it's a function of r. And as a reminder, what does it mean to be a function of a variable? It means the only variable in the formula is that letter. So in this case, the only thing that can change the value of a is r. Everything else is a constant. Pi is a constant. So we just put r into this equation, it'll give us new values for a. So our final answer, I guess, for a is a function of r. Let's simplify this. Pi on top, pi on bottom. 2 r's on bottom, 1 r on top, so they'll cancel. And then we have 2 times 1,000, that'll give 2,000. So this is 2 pi r squared plus 2,000 over r. You could simplify it a little more by taking out a common factor, but this is basically, I think, where we'll stop, because this is the essence of the answer. And let me check it with my answer just to make sure I'm okay. 2 pi r squared plus 2, yeah. And my answer's okay. You might remember this. We did this, the question almost exactly in Unit 2 already. But it's a really nice question because it looks difficult. There's a lot of different steps, but it actually is not difficult once you understand it. It makes a really good multiple choice because you either have the answer or you don't. If you have the answer, it means you probably understand it. If you don't have the answer, you probably don't understand it, which means you don't get the marks. All right? Anything I can clarify for this question before I move on to the next? Take a chance to drink my cold coffee. And a little bit of water. Well, you're my mute class today. You're all so quiet. I guess you'll just tell me if you need something. So lonely. All right, Unit 3, conic sections. What are the coordinates of the foci for this ellipse? Anyone remember how to do this? This is an ellipse. You might remember that if we need foci is the center values plus c in a way. So I'll get to that after, but we need our key points, the key points of an ellipse. First of all, we need the center. We're going to need A. We're going to need B. And we're actually going to need C as well. A, B, and C. And you may or may not remember how to get them. In order to get A, it's the length of the major axis divided by 2. So I can write that out here. A is the major axis over 2, or the length from the center to the edge. So if this is the full length of the major axis, this is A. Okay, so you can see it visually, hopefully. Let me make the colors match. You should be able to see that it's 1, 2, 3. Okay, A is 3. What we normally do once we get A is get A squared. So let's just say A squared is 9. B is the minor axis. B has to do with the minor axis. Just like A has to do with the major axis. what's the length of the minor axis? Well, if I look at the diagram, I can see that my minor axis from the center is 2. So the full length is 4. You can divide it by 2, it'll get 2. Or you can just look at it and see that it's 2. This is 2. B squared is 4. C, you might remember the formula, you might not. C for this is a squared minus b squared. Remember that for hyperbolas, it's plus. For ellipses, it's minus. I think I have that right. I'm trying to remember now. I think it's correct. I think it's correct. I hope so. C squared, sorry. C squared is a squared minus b squared. We already have a squared and b squared. So that's 9 minus 4. That means we have root 5. All right. I might as well keep my colors consistent just so you know where everything's coming from. The reason I needed C is because it's related to the foci. If we look down close here, our foci should be somewhere along the major axis, probably somewhere around here and here. I'm not sure, but if I was to draw a little sketch with if we just draw our major axis and our minor axis, the foci should be somewhere along that axis there, okay, along the major axis. So how do we get it? What we need to do is consider the center point. We have x and y values. We know that it's going to be on this line here, which is down 1. So the foci will be -1, and then you have to add to the center. So we know that it's something in -1. We take our original center value for the x value of the center, which is -2, and then you add c. So let me make this more clear. Really, the only thing is happening here that's related to c is there. I'll recap this in a second. I'll clarify what I'm doing in a second. Those are my answers. Okay, so let me just clarify what I just did. In order to get the foci, you need to get A, B, and C, especially C, because C is where the foci comes from. So A and B are gotten visually from the graph. A and B are both gotten visually. C is by this formula. It gives us root 5. Root 5 is the distance from the center to the foci. So really what I should have drawn is that there's going to be some distance. Let me get my colors back. There's going to be some distance here from the center. That will be the distance C. And that'll be a distance C as well. So you take the center value and add that. So if the center here is already at -2 and -1, you're taking the center value, you're going to add C for one of them, and you're going to subtract C for the other one. So when you have your center value 2 and 1, 2 and 1, 2 and -1, I've added C to get one of them, and I've subtracted C to get the other one. So hopefully that's ringing a bell. Hopefully you're seeing why you need to do what you're doing. So yes, this is an involved question, but there's actually only a couple steps. Like you can get this really fast, get this really fast, get this really fast, and then if you understand how foci work, that's the question you're going to be expected to do on the final. Okay, so big hint here, you'll get an ellipse, you need to find the focal point. The ellipse might be in any of the quadrants, and it might be stretched upwards, it might be stretched sideways, but if you understand the basics, you'll be able to get the answer. Okay, So I'll give you 5 seconds just to say, sir, if you need to ask me any questions. Other than that, I'll continue forward. Yes, Abdullah. So you just took the chance to say sir, and you didn't have questions. Good. You got me. You got me. All right. Moving on. I love these questions. I don't know why, but I love it. I think it's just because it's so, I find it very easy because it's just a nice, calming process that's always the same. But let me get to the point. You might not even know what I'm talking about yet. It says you're given the equation of ellipse in general form. So this whole thing is our equation in general form. It says what is the equation in standard form? So really, we're going from general form to standard form. And we need the standard form of an ellipse. So the standard form of an ellipse is this. Is it plus or minus? Plus. And A or B, I mean, it doesn't matter. It could be either one. We don't know, but the form is this. We have a squared on top, a squared on top for the other one as well, and on bottom we have constants, and on the right side we have a 1. Remember that for a hyperbola, it would be minus, for example. So maybe I should just remind you that. If it was a hyperbola, it would be the same thing. My goodness. If it was a hyperbola, really, similar structure, but with a minus. This is an ellipse that we're worrying about, though. And there's others, but I want to show you that there are different forms. Please go and check and see what the differences are yourself. This was all done very clearly in the notes. So let's do our standard form. First of all, what we need to do is group the variables. So rearrange your formula so that they're grouped. What I mean by that is I see x's here. Actually, they're already grouped. So I guess that's easy. Normally, they're not grouped. This would be over here, but that's okay. They're already grouped. So it's kind of a pointless step. I'll write it anyways, just so that if you had to do it, you would know. Normally, it's not grouped to begin with. So we have our x's together. We have our y's together. Once again, of course, I didn't change anything here, but if they were in different order, you would have to do that. And then the second step is factor. Factor those two groups. So what do I do for the first one here? I can see that I have to factor out the constant. You're not going to factor out everything because we need to complete the square, if you remember this. So take the 4 outside, it'll give you this. And this has a 9 in common. It'll give you this. The right side we haven't touched yet. So we've now factored out our constants. And of course, you should hopefully see that our constants are these. What do I do next? I kind of just gave you a hint as to what we do. We need to complete the square. So I'll write this out again. Normally I'll skip some steps, but I want to show you everything. We need to complete the square, which means we need to figure out how to make this into a 3-term polynomial. So a trinomial. We need to find that third term. So in other words, we still keep what we have, but we leave some space to figure out what that number is going to be so that we have 3 terms and we can factor that into 2 squares. So what we do, hopefully very simply, take this number, divide it by 2, and square it. Divided by 2 is 2, square it, you get a 4. So it's just a 4 again. Same idea with the next one. Take the 2, divide it by 2 and square it. That's a 1 squared. All right, we get a 1 out of this. We are not allowed to just magically get new numbers on one side of the equation. You have to do the same thing to the other side. So what we're going to see here, let me get back my proper colors. This 4 times this 4 gives me a 16. I'll probably erase that after. And then this 9 times a 1 gives a 9. Okay? So not a lot to do, but of course steps you need to understand. I'll erase these. Hopefully that's okay. I think I just deleted something, so 1 second. You might know where I'm going with this. You should know, I mean, we've done it before. We need to simplify the right side and we need to factor the left side. So I'll just say, it's not really simplify, but I'm going to call it simplify anyways. For this part here on the left, this is this. I know that because you just divide this number by 2, it comes here. Or you can actually factor that. So you don't need to write this down. But if you were to factor this, what 2 numbers multiply to make 4 and add to make positive 4? Well, it's a 2 and a 2, which is x plus 2 all squared. Okay, so this is why it works. It's always the middle number divided by 2. But if you wanted to factor it, you can. And on this side here, it's 9 plus y. Y squared plus 1. Y plus 1 all squared. Sorry, it's early. 11 plus 16 plus 9 is 36. That's good. It should be a square number. I usually give you square numbers to make your life easier. Not always squared. And then your 5th step is, I guess, to divide. You don't even need to think of this in terms of steps, but some students like it. So divide by the right side. The right side is a 36 right now. We make it 1. So we divide everything by 36. And that gives us x plus 2 all squared divided by 9. Y plus 1 all squared divided by 4 equals 1. And this would be our final answer. And let's see if it's right. Yes, yes, yes. Okay. Let's look at the whole thing now that it's all done. I guess 5 steps, and you could probably skip some steps. In fact, I actually sort of skipped a step from here to here. The only thing I really did, the constants in front here, 4 divided by 36 is 1 over 9, which is why I got this, and so on. But I hope that that's okay the way it is. All good? I hope. Again, it's a review, so it should be good. You've already had to know this stuff for the tests. But I'm not crazy. I know that students have lots going on. I was a student once too, not that long ago. And I'm trying to give you some good tips, some good reminders as to what you might want to expect on Saturday. So just stop me if you need me to, but we're almost at the end of this. Unit 4, trigonometry. Says, what is the equation of the graph shown in terms of sine, and what is the equation of the graph shown in terms of cosine? So it's kind of 2 questions in one. We need to consider the graph in 2 different ways. But our basics are always going to be the same. There's 3 pieces. The first piece is going to be amplitude. The second piece is going to be period. And the third piece is going to be displacement or phase change. And it's only displacement that changes based on the sine or cosine. Amplitude and period are going to be the same no matter what. So I'll split these up. Let's see what we have. Amplitude. Amplitude in this case, actually I can't, it looks like it's 2.5. I didn't mean to give you a weird one. I meant to give it as 2 or 3. Actually, I think it was supposed to be 3. Because halfway here, sorry about that. It's supposed to be a 3. That was supposed to be easy. Just don't freak out about that. It's just 3. Period. That's one that students tend to mess up, but I like to take the easiest possible way. I look at this point compared to this point. And oftentimes that's enough. I'll keep saying the same thing. You can always take any 2 points. You could take these 2 points. You could take these 2 points and subtract them. You could take these 2 points and subtract them. But why not make your life easy and look at the difference or the length of time between here and here? Or long story short, just take this number, right? That is the period. And so the period is 4 pi over 3. The displacement is the tricky one. We need to look and say, okay, we're going to do sine first. Maybe I'll make it a blue. Our sine graph normally starts looking like this. This is sine. So we look for the intercept right there. So I could either choose this, which would mean our displacement is that, or more logically, you would want to choose this. So that means our displacement is this. Okay, so it's shifted just a tiny bit. Negative pi over 6 is our distance. Okay, that's our displacement. If you wanted to write the other one down, you would say it's been shifted 7 pi over 6. Okay, negative pi over 6 is closer, so we normally take that one. That is not the answer because we need the equation to look like this. A, y equals a sine bx plus c. So we need to solve for a, b, and c. A is easy, we have it. What's b going to be? Well, b, what's the formula for period? Well, period is 2 pi over b, which means that b is 2 pi over period, which means that it's 2 pi over 4 pi over 3. And you need to work that out. If you work that out, I'm just going to set it up in my calculator. It's 2 over 4 over 3. 3 over 2. There's a pi on top and bottom here. They will end up canceling. It's 3 over 2. Our displacement, our formula for displacement is negative c over b. We're looking for c. So if you rearrange this, what you get, you might remember this, is negative b multiplied by a displacement. Negative b, what's b? We just got it, it's 3 over 2. The displacement is what's up here, it's negative pi over 6. So we need to multiply those out, which I can see just by looking at it as 3 pi over 12, which simplifies down to pi over 4. I'm going through this quickly. I'm not color coding it like I normally would because we've done this stuff before. But if you have trouble keeping up, just watch the video again later. Or you can ask me in the chat right now. I'll go through anything that I confused you with. But let's write out our final answer now. Y equals A, 3, sine bx, so b is 3 over 2, 3 over 2x, plus c, so plus pi over 4. That's our first answer. Okay, that's our first equation. And I can see here that it's right. So I've got this one so far. In this little space, and I don't need a lot of space for cosine, the only difference is the displacement. So in order to get the same graph as a cosine graph, it's still a and everything else, but it's cosine of bx plus c. The difference is c will change. Everything else will stay the same. So all I need to do is find c again for cosine. C is, sorry, I need to, I'll need to get displacement again. So displacement for cosine. Once again, why am I getting displacement only? It's because amplitude is not going to change, period is not going to change, but the displacement will change because cosine looks different than sine. Cosine looks like this. It starts at a different place. Its y-intercept is up at 0 and 1. So I need to look for this peak and tell how far that's moved. And we can see it's actually moved by pi over 6. Instead of being moved to the left, negative pi over 6, it's moved to the right, positive pi over 6. So our displacement is pi over 6. So in this case, it was negative pi over 6. For cosine, it's going to be positive pi over 6 because it's been shifted in a different way if we look at it from a different point of view. And now we can work on the rest. So let me see. Sorry, I thought I was going to be able to see more. C is negative b times d once again. B is not going to change, so negative 3 over 2. Displacement will change. It's our pi over 6. And that, instead of giving us a positive pi over 4, we'll see that this gives us negative pi over 4. So long story short, y equals 3 cosine 3 over 2 x minus pi over 4. And that's the end of our story. Before you ask, because some students are saying, seriously, sir, this is one multiple choice. Are you kidding me? And I say, sort of. This is two possible questions in one. What I could give you, and what I plan to give you, is I'll give you the graph, and I'll ask you what's the equation in terms of sine, or I'll give you the graph and ask you what's the equation in terms of cosine. But the basics are the same. You'll always follow the same procedure. You look for the amplitude, you figure out the period, that'll give you B, and you figure out the displacement, that will give you C. And put those three things into the equation and got it. So yes, I'll be asking you to get the equation of the graph as a single multiple choice, but not of two different equations. I'll either say in terms of sine or in terms of cosine, right? And if you know the difference, you should be okay. Can I just get a general idea, like on a scale of 1 to 10, how is that? We've done it before, but I wanted to make sure you saw this because it's been a while since we made the equation of the graph. All right. I can do another one if you want me to go into the notes and find another one, or you can review the video. What would you like me to do? We can either move on or do more practice on this. So Sarah wants me to move on. Can I just get a couple more votes? So it's a democracy. All right, we'll move on. If you, I'm here but not here. Okay, so watch the video again if you need to. And if you want me to explain something else to you, I have no problem sending you any information directly, okay? So between now and Saturday, and this goes for anyone watching the video too, I don't have class. So I'm still working. I just have to find other things to do. So some of those things can be helping students. I can even start new Zoom classes with you one-on-one and we'll go through it, okay? So just let me know if you need help before the exam. I'm here for you. So Unit 5 derivatives, I gave you quite a difficult question to prepare you here because I wanted you to be able to review a few different topics in one. So when we look at this question, it looks familiar, but also not familiar probably. It says, consider this graph. So this crazy looking graph here is what this looks like. This is implicit. We can tell it's implicit because there's y's in the middle. And it says, find the equation of two things. We need the tangent line and we need the normal line to the graph at this weird point. So normally when I'm asking you for the equations, you get the derivative, you substitute your information, and then you use y equals mx plus b. We're going to do that today. For this question, we're just going to have to do it a couple times. And it's for an implicit function. So the derivative is going to be a little tricky. So let's just get started, okay? Let's just do this. Enough of me talking about what I'm going to do. Let's just do it. First thing is the derivative. So the derivative of 3x squared and so on. So this is 6x minus 3y squared, and that always gives you a y prime. So I'll remind you of that. Minus, and this is our product rule. And there's a little bit of a trick here. It's got a minus in front. So before we start the product rule, we should open some brackets. And that'll make sure that the sign doesn't get lost. Okay? So there's a minus here. Let's put the minus in front, use brackets for the product rule. And you won't mess it up. So the derivative of the first one times the second one plus the first one times the derivative of the second one. And that pops out a y prime. The derivative of the right side, many students say it's 5. It's not 5. It's 0 because we're getting the derivative of everything. So not 5. Students tend to leave that constant in and it messes up the whole question, okay? So now we need to solve for that y prime any way that we know how. So the first thing I'm going to do is I'm not going to touch anything until I distribute this minus inside. That's a step we haven't dealt with very much before. So this is going to be 2x y prime equals 0. So once again, to remind you, I'm looking for y prime because that is the derivative. I just need to rearrange for it. So I'm going to bring everything, all the constants to the right side. I'm going to bring this over, and I'm going to bring this over. Not just the constants, anything that doesn't have a y prime term. So I'm going to factor out my y prime. And bring my other information to the right side. And then I'll divide. Remember, I'm looking for the derivative, y prime. Y prime equals negative 6x plus y squared over negative 3y squared minus 2xy. So that's a little bit fancy. That's kind of a complicated looking derivative here. I'm going to make this a little smaller so I fit it on the page a bit better. But, you know, you can keep what you have. So this is our answer for the derivative. Now, the first step is the derivative. The second step is sub in your information. Normally it's sub in x, but we have x's and y's. So we need to sub in x and y. The x and y I'm talking about are up top, x and y. That'll give us our slope. So y prime in this case equals -6, or x is 0, squared plus -1.71 over -3, -1.71, square it, minus 2, 0, -1.71. So what you'll notice here is that anything with a 0 in it can cancel. We'll cancel the whole term. It means that our y prime is -1.71 over, what's that bottom? -3 times -1.71 squared, -8.7723, weird numbers, I know. That means that it is, drum roll please, 100 over 513. I'm going to just compare it because it's easy for me to make a small mistake on this. I'm going to compare it to my notes. I think I forgot to square something. I think this bottom number might be wrong. No, I think it's, maybe it's okay. Sorry, I'm just comparing to my notes. I don't want to have messed anything up. Oh, I did something really silly up here. I put a square where it wasn't supposed to be. After I resized it, I accidentally moved the square, so it's on the y. Sorry about that. So that just removes this square. Going to do some damage control here. Plus squared. And then on top, it's negative. Okay, sorry about that. It's -1.71. Square it. And on top, we have 2.9241. So again, it's easy to make little mistakes here. And this gives -1/3. So lots of steps, but the big steps are the same. One derivative, then you substitute in your information. Why did we do that? Because this gives us the slope of the tangent line, which is going to be -1/3. Most of the work is done now. It says I'm going to need my normal line too. So in order to get the normal line, I get the negative reciprocal. So I get the negative reciprocal. Just flip it over and make it positive. Or we get -1/3 and be positive. And the third step is our y equals mx plus b stuff. So let me just separate these steps a little bit. Just in case I need the space. So put in your information. Y equals mx plus b. So I'm going to be, this is going to be my tangent. I'll call it y t here, okay, y tangent. So -1.71 equals, what's the slope of the tangent? It's -1/3. The x value is 0. The b is what I'm looking for. I have a very convenient 0 there multiplied, so it deletes the term. That means that our b is -1.71. So I already know my slope of the tangent line. I'm going to do the same thing for the normal line. For the normal, or I'll say b of the tangent. I don't know the best way to do it. B is going to be the same no matter what, actually, even if I put in for the normal. So -1.71 equals 3 times 0 plus b equals -1.71. I'll recap that. So if I lost you there, I'll get you back. So the whole point is I'm trying to find the b value for the tangent and the normal. So for the tangent, the b value ended up being this. For the normal, b ended up being the same. I just substituted my numbers in. I just changed the slopes. It ended up being the same thing. You'll notice, hopefully, slope of the tangent, slope of the normal. And now I just need to write out my final answer. So y for the tangent line is y equals mx plus b. So mx plus b. Normal line, mx plus b. And if I compare that to my answers, they're the same. I feel like if I was going to leave you anywhere, like lose you at any point, this would probably be the question that I would lose you at. But what we would find is this is the point we're talking about. The tangent line, if you were to graph this on Desmos, all this stuff, the tangent line would look something like this. The normal line would be something like this. That's the whole point. And with that, our derivative, our substitution, our y equals mx plus b stuff, and then the final answer, that is the whole problem. I'll make it very clear to you, if I was to ask you this question on the final, I would not ask for both lines. I would say find the equation of the tangent line, and then you just worry about tangent. Don't worry about negative reciprocal. If I ask you for the normal line, you need to do the whole process, and the extra step is this negative reciprocal step down here. That's the only difference between the tangent and the normal line. Okay, that is every single problem that I have prepared for this course. And so congratulations, I'm done doing the review. At this point, we have 30 minutes that if you want to ask any questions, this would be the time to do it. Otherwise, I guess it's goodbye. And unfortunately, we only have 6 people here, so it's not goodbye to everybody, but it's goodbye to you. Sad at times. Anyone have any questions, or have you all drifted off into space already? Am I saying goodbye to an empty room? So any questions before I close it up? All right. I always find this weird. In person, it's difficult, and even online, it's difficult. I don't like saying bye. I don't like having end of term stuff because I might never see you again. I might never talk to you again. And I can't even have the exam room to be like, good job. Give you a little pat on the back and say, hey, maybe you should put a negative there. So I don't have that choice. I will see you on Zoom because we have to turn the camera on, but I won't be able to actually interact very much. So yeah, if I teach physics 2, that'd be great. Otherwise, maybe I'll see you in math 3. All right, all the best. I'm going to stop the room and stop the recording here. I'll actually stop the recording right now. Bye-bye.